Okay, thank you very much. Thank you very much for the introduction, and we are very excited to have this collaboration with the City of Calgary. Thank you very much for Jason, Monique, and all the Smart Cities team that has been very much working with us for the last few years, and in developing a lot of projects and experimentation and testing a lot of new ideas. So the RoboCraft project I'm going to talk about innovations on learning and program, is a collaboration between the Laboratory for Integrated Design at SAPOL, at the School of Architecture, Planning and Landscape of the University of Calgary, and the city. And how did this project kind of come about, or what is what we are trying to do through RoboCraft? So for the last 15 years, my lab, we have been trying to research how can we use shape, geometry, the way that we make things to make shapes that are more efficient and more sustainable for the built environment. So shape that use less material is closer to the source, and that can be better built. And we have also been working a lot with robotics, with robot arms, to help us fabricate and deliver a lot of these forms. And we believe that that could be the solution for a built environment that changes, that adapts, and that do not have to be demolished, or is not abandoned, or is not empty. So if we can create buildings and spaces that are interactive, where people want to live and are more efficient. And what am I on? And something very interesting is that on the car industry, from the 1900s to now, you can see a big difference on how cars were made and how they looked, and how cars are made now and how they look. It's beyond tech. It's not only that we have a smart drive and the GPS and all of these sensors that are a bit horrible of reverse and this and that, but it also looks different. It's also different. So we really are trying to go beyond just adding a layer of technology, but trying to go into how things are made, built, and designed. In the built environment, it's not the same. Buildings look pretty much the same, if not worse, than 100 years ago. So why is that happening? Why our buildings are not like our cars that look so much different right now? And that's where a lot of our work kind of really comes from and started to take shape. And this is something I find really interesting. Like the patent to do reinforcement bars is from the 1866 or 1900s. And when we built all the towers around the city, when we build concrete, we still do this kind of reinforcement bar. 124 years, we still use exactly the same tech. And if you tell me, hey, Alicia, well, in Calgary we don't use so much steel like in other countries, the patent for CLT, for cross-laminated timber, is from 1923, 101 years old, when the first CLT lamination was done. How can we keep building with the same technology and not question it, and just think that we're going to achieve efficiency and sustainability through adding tech or adding kind of more sensors? And that's where kind of our research kind of really tries to focus on. Of course, we use AI, and we love AI as everyone else. We know that AI can give us a lot of great ideas. The only problem is that we still have to build them. So how do we build all of the new ideas that AI can give us? And that is for us where this RoboCraft project comes, and we are trying to use and work here in the wave. We are going to have a big robot coming on, where his little brother is there right now, but he will be bigger. And we are kind of looking at how can we use advanced manufacturing to design and fabricate. We're going to focus on urban elements that are near site, so we're going to fabricate them here. As a prototype, of course, eventually we aim the robots to be moving around, are customizable, so they are different, not generic, not mass-produced, not all of them the same, are participatory, so citizens, the people that live, that will use them, has an opinion and can design them, and also affordable. What we aim to reduce with this is the timelines, the environmental impact on fabrication, but also transportation cost, carbon footprint of bringing stuff around, test novel fabrication methods, and of course, working on upskilling and training, which is kind of one of the main goals of this RoboCraft project that we're going to be developing here. Why robots? because robots are flexible machines. So one single machine, the arms that you see there, they're bigger bodies. The one that we are getting will be like this one, but white, not orange. They said no orange here. So it's that guy. And so they can do like pick and place, for example. They can help us assembly stuff. They can help us 3D print, something that we're going to be doing a lot here, 3D printing. They can also do milling operations. That's a lot of the work that we do, research that we do at the lab, and also my own research is a lot of digital timber. And also they can do band sewing or any other thing, circular saw. They wouldn't allow me to do that here, but we could do it if we want. So anything that you can hold at the end of your arm, the robot can hold at the end of his arm or her arm, depends. And the robot can also do it, right? So that's where we are. What I'm so fascinated with robot arms, and we have been working for like 10 years or more than 10 years on them. And this is a hot wire cutting, for example, again. And the interesting thing is that when we talk about how are we going to do these new shapes, are we going to be making up stuff and getting more expensive and crazy stuff? No. Actually, a lot of this is learning from the past, from stone structures, from brick, from structures that maybe were more efficient, that maybe were more sustainable, that were using materials closer to the source. So a lot of the learning from the past that we don't do anymore, we can start doing it again with mass customized robotic processes. So for example, this is the same stone cutting, this is hot wire cutting with robot arm. Each stone is different, each piece is different, right? So we are trying to go to learn from the past, those efficiencies, see how we can innovate and how we can bring them back to robotics. This is the guy that is there. Right now he's drawing, but he also does hot wire cutting. So he's kind of trying to test a lot of these ideas, even at the smallest scale, and that could also happen at the big scale. So whatever the small robot does, the big robot will do. So we are comfortable in testing our ideas at different scales, and just we don't have to test at everything on a bigger guy, right? So this is Nachito, that you can see him down there, and kind of hot wire cutting. And these are some projects that we did, for example, with hot wire cutting, foam, trying to see how can we reinvent how we live. However, it's not only about reinventing these shells and say, well, this is a shell 5 centimeters thick, concrete, has been standing for 12 years. We built it in 2012. So, like, trying to learn from the past, from fabrication methods that were more efficient and more sustainable, but not only. We don't want to innovate on everything. This is a project that we did in 2018, Knit Candela, another shell with a fabric formwork, and also like very, very thin, 5 centimeters thick, all concrete, lots of people there. But also, how can we mix these with traditional ways? We don't have to innovate in everything, but how can we make critical innovation to change how we live only where we need it? So can we mix these with traditional methods? Can we mix these and actually give people a better city that is more beautiful, more elegant, more efficient, while still keeping a lot of the traditions of how we build? So we are looking at this intersection. It's not everything is new, but the intersection between the new and the past. So there's the engagement with the city. Is about advanced technological development in materials, in machines, and in intelligence. Those are the kind of the 3 aspects that we are tackling through the RoboCraft project. And I'm going to show you some examples of work that we are doing currently with some with the city past projects that on these different areas. So how do we talk about engagement? What do we mean by intelligence and engagement? This is, for example, a facade that we are developing for one of the buildings in the downtown. And here the idea is that citizens can come, or users, and make selections of how they want it to work, but we are giving them feedback so that when you pick something, you know the environmental footprint, the amount of material, the amount of fabrication time that it will take. It's not like if you go to IKEA and have your configurator to do a kitchen and you don't know where it is coming from or where it is doing. So can we make furniture and design as food that you see the ingredient content and you know where it is? Sort of know how many calories you have, how many carbs, you can know how much material it is, how long it took to do. So we want to really be very transparent with this information. So the researchers in my lab, some of them you will meet here also, are working in these kind of participatory platforms where people can come, select, and all the analysis are doing at the back end. So as people are doing selections and are peaking, we are kind of analyzing all of those to tell them, well, that will be more efficient for energy performance, for thermal performance, for material fabrication, for robotic fabrication, for amount of material that you require. So as much information as possible giving back. And everything is, of course, calculated. So we are working in a lot of these platforms. It's something we are aiming to do also with the robot, with the, part of the RoboCraft project, to have these where people can interact. They won't know, but they will think that they are designing, but we can give them as much information as possible. Be very transparent. Every decision you make, how much it will impact everything in the supply chain. So this is the timber bending, for example, for that facade project. And then again, robots bending. So in this case, we the user is selecting, is moving back and forth, is picking something, and then the robots are bending it. And then after the robots bend that curves, after being analyzed, they mill, they cut. This is one of the prototypes that we built for this project. Like everything designed by humans with our input, giving them feedback. So that's something that we want to achieve through this project. Other thing, and that's the bench that you see there, one of them. Other is like in this case, we were working again with the Downtown Association, with Jason also. Like, we want to do benches, but they are very big, very volumetric. How can we carry them? Can we make them out of flat sheet material? So then you only bring flat material, you bend, you fold it on site, and you get strong results. It's a lot easier to ship sheets than to ship benches, right? So we kind of work on that. We did the structural analysis, and then we did these benches out of like aluminum, thin sheet aluminum, 3 millimeter thick. But by the curvature, by the shape, by the form that they have, they are really resistant. And they have been used a lot of times in different events, Chinook, Blast, and the Korean Festival. And it's super exciting every time I see them somewhere because they are still there and very, very resistant, right? With very, very thin material. So really trying to use as minimum amount of material to create things that are close to the source and not having to transport them. And I think these were when they were new, first time we deployed them. So very exciting collaboration. So this is something that we are definitely going to keep looking at, right? Fabricating, smart use of materials and close to source fabricating. How can we deploy more of these techniques that don't require to transport big volumetric stuff and can allow for thin material to perform very strongly? Also, this is another thing we did. We took the robots. One you will see Freddy. He's right now there doing some face tracking, but here he was drawing. So also, how can we bring this outside of just these doors or this building and bring them closer to people? This is an engagement event that we did in 2022 also with the Downtown Association, facility with Jason also, and like kind of bringing the robots to people and allowing them to engage and to have a say on that. Very exciting that we had like tons of people participating. We had cues, and in this case, the robot was just like, was just drawing. So people was like, one robot was taking a photo, other robot was drawing. And it was so exciting to see the enthusiasm in the city for the tech, right? Like at some point we had a line of like 30 people outside and the researchers were there. And some people, we told them come back in the afternoon because we were just delayed drawing so many robots, so many faces. People will come back. Even next day, people will come back to pick up their drawings made by robot. So seeing the level that the city has of enthusiasm is really inspiring and has really motivated us to keep this collaboration going and to work harder to make it happen because it's really, really, really fascinating. So this was, these robots were like for 3 weekends drawing and he's now there. And then another project that we did last year, also with Living Labs with Anne, was like using topology optimization. For example, this is a shell that we built in 2013, and you see that it's full of holes. So the holes are not because we like them. I mean, we do like them. I love them. But also it's because that's where there is no stress, right? So that is where the structure was not performing. So we remove that material, we make it look very beautiful, but also we use like 70% less concrete than if it was all full. So we kind of look at this, and the question here was, can we do the same if we reduce all the material, but can we actually make something, make the concrete do something else? So we developed this bench, we remove all of this, all of the filling using topology optimization, and we put a sand battery inside to kind of heat it, to kind of think things that heat, can it capture electricity, can it heat? So these are some of the initial tests at the lab on the first little prototype that we had. And then this is the full prototype, again, everything hot wire cut with the robot arms, and then casted, and then inside this bench, there was a battery, there were sensors. It was at the Glenmore for like 6 months, I think. Now it's removed, and kind of hitting when people kind of arrive. So kind of really trying to see how can we engage on this through using different algorithms. So really like kind of the idea of leverage technology to create sophisticated, dynamic, and customizable processes. And that's where kind of our project lies and what we want to bring to the wave and to this project. And we're going to be working a lot with 3D printing, so the big robot will be doing a lot of 3D printing, concrete, plastic. We are looking at different mixes for urban elements. This is like just a clay extruder, so we're going to go a bit more sophisticated than this, but try a lot of 3D printing. And the idea is to have, flexible and adaptable technology on materials and machines. Near site, so low carbon footprint on transport, no carbon footprint on processing. We're going to try to like also engage, we're engaging with a lot of like local companies. Customizable design and fabrication, where the users, the people from like city people, designers, support, everyone can actually have a say on the design. It's not top down, but it's bottom up. And then upskilling and training, and really trying to use technology for social innovation, for new ways of building and new ways of looking at the built environment. And I think that these are the main goals of the RoboCraft project that will be installed here for a few years. Thank you. Oops. Oh.
Any questions? Yes.
I want to know, through what methodology do you employ to determine how much, when you are applying a curvature to, as you mentioned, a sheet of material?
Yeah.
How much, what's the methodology to determine how much curvature you can apply to that material before it's stressed to the point of breaking? And then also, when you design material, what other considerations or the methodology behind environmental factors like temperature, extreme temperature, and also UV?
So we simulate that. So we have tools to simulate environmental performance, thermal performance. For the curvature, we also simulate that, and we also test physical. So we do a lot of physical digital comparison, like with the aluminum benches. Sorry.
And just, I can't speak to that. I'll let Alicia catch her breath. But so with this project, we talked about the different kinds of things we can do, right? We'll print in concrete, and we've got another project where we're the UC with Alicia and the U of A and Zaha Hadid Architecture are printing in metal. And so as much as the 3D printing is less of this science experiment, it's also a test of our policies and our processes, right? Like the 3D metal project, to get it through to development permit, we're actually using it as a playground equipment, because that's where it had to fit in. So we get a chance while the students are doing two things. They're gaining a real world project, and they're helping be part of city building, but we're getting to understand where our policies aren't ready for what's next, right? And so it gives us a chance. Okay, so this is our first 3D metal pavilion. We're going to have more of them. How do we get our permitting processes ready for that? And I'll let you.
Yeah, fine. No, sorry. Yeah, sorry about the curvature. So we have been working with curvature for a very long time, because we know that curves are more efficient, and we know that in nature there are no straight lines. So that's where we really kind of know that they will always be stronger, that the strength through curvature is given, like any shape will deform into an arch, into a catenary. in tension when you flip it is in compression. So, but with the aluminum benches, for example, we did a lot of testing, a lot of bending, and then we start to capture that information digitally to know how to calibrate our digital with our physical simulation, especially when we talk about concrete printing or steel. There is a lot of humidity, a lot of factors that affect how the material will perform, right? So we do a lot of calibration and then a lot of simulation. So a lot of the work we do is simulation. Especially for all the curvatures, but we know that curve is better. Yeah. Sorry for the cough attack.
Maybe we could talk about again, we talked about the students' resumes, their experiences is all portable, right? Especially when we did that bench, there was a big fear we were losing young people. And through that project, right, yes, their resumes, experiences are portable, but their professional network isn't. And those students met with Calgary Downtown Association, Arts and Culture, myself,
Correct.
right? So they build their professional network here. They get to be a part of city building, which gives them a little bit of pride. What benefit do your students get out of working with the groups in the city?
Well, yeah, I think that they get to know more about the whole process, right? Because sometimes, like in the architecture school, maybe they think that that because they are designing something, they are going to change the world, right? But then they kind of don't get exposed to there is planning, there is a structure, there is all of these other things. There is people engagement that you need to consider, and when they engage with the city, they kind of go through some of the bureaucracy, but they also kind of get engaged with the whole process, right? And they also get their designs being used or their products being used. So it's a full design to full-scale fabrication cycle, which I think is super valuable because they go beyond a model. They go for the real thing. Yeah.
Great. We're here, and then we'll go to yeah. Okay.
What are you most excited about with the future of all of this?
I'm excited about a more beautiful and sustainable built environment where people really can participate. And I think that I do find it conflicting that our buildings look worse than before. And I think that we have all the power to make that change.
We'll go stand because I saw your hand up, and then we'll go back to the back. I'll get you.
Sorry.
Senator, you had another question?
There's a question.
Yeah, I'll get. Yeah. Okay. Sure, Chris.
Yeah. You talked about efficiency and sustainability. What if you could speak about scalability and what are the considerations for scaling something like this?
With timber or with 3D printing, we do everything in pieces, right? So, for example, with the facade project, the size of the element comes from the robot, from the size of timber, and from the connections and the joinery between them. So that's a very important thing. The scale, it's depending by the machine, and that's something that I think is really a paradigm change on the way we build, because right now, the way that we build, the dimensions are coming from the vehicles that move material, right? Whatever cannot be transported in a lorry cannot be taken on site. So something that we're trying to see is how can we change the dimensions of with the concrete printing of bricks, of what is a brick when you have a robot building, right? It's very different than a brick when you have a hand, or bricks are made on the human hand, right? When you change, the size is not anymore a human, but it's a machine. How does that change? When transport doesn't matter, because we can, like on the box, we can bring the robots near site, be fabricating there. So then it doesn't really matter if it fits in a lorry or not when it's finalized. So a lot of those things, I think, is the work that we are doing. And for scaling, for example, this piece here is part of a large facade that we did last year for the Venice Biennale in Venice, and it's a full facade, so it's made out of components. However, the dimension of how we got the size of this component is based on the size of the robot that was going to fabricate it, and the size of and this is a CLT. Laminate is a CLT that we did in house, tested and also milled. So it all depends on the machine size. but definitely panelizing. For concrete printing, the other thing about shells or about curvature is that if every block comes together, you will get efficiency, right? You don't need reinforcement, so it will stand. Yeah.
With our fleet fabric shop. So we have a fabrication team that basically done lots of vehicles in terms of fabrication designs and cuts. So it would be cool to have you guys show.
That would be really
I
nice.
don't know if any equipment here, but I do see that's an opportunity.
And that's kind of one of the pieces of this experiment is that we used to have the carpentry shop, right? And then things became very IKEA and very modular, and that ramped down. And now we're getting to the point where design is democratized and customization and in-house build is possible with 3D printing. Actually, one of the great things about having Alicia's PhD students here for the next several years. So Maddie was able to design actually the grippers for the TV on Freddy were all printed in our 3D print with our 3D printers, right? So we're getting these custom adaptations or on the fly, really quick tools and machined parts are really easy to develop. And so maybe, right? Maybe again, the science in the 3D printing is out there. That's not the innovation. It's the experiment for us is seeing whether it's ready for city to start using. We talk about upskilling. What are those skills that we need in-house to do more of this, right? How do we become Maddie and be able to print the custom builds that we need? And then, so the skills and the policy and the durability. I think the other piece we talked about is when a car hits a concrete bench or that pavilion, right? That we can crush it and reprint with that same material. So the carbon footprint of concrete is huge, but if we can reuse it, right? Or if we can melt down the plastic from our other 3D printers and turn that into more filament to print again, that's all things that we can do with the university.
Yeah, and I think that, something we have been also working for a few years now, this is on the shop, on a robot shop, is the whole idea of upskilling, right? Of training, of making these robots being more out there and being part of normal fabrication processes. So that's something that we have a shop, and then we have really been kind of developing that part into how can we bring pride back to the construction industry. And I think that is something very fundamental because the construction industry or all of the building industries are kind of lacking pride. Since I was a child, I was always in construction sites, and it was always exciting, fascinating, right, for me to be there and seeing everything going on. And right now you see that people are not really excited to be there anymore. And we have been to bring in some digital layer at it, trying to make it more attractive again for young talent. And I think that that's something that we really want to develop and to explore.
Sandra, one more, sure.
Okay. You made reference to ancient structures, and some of them they were quite novel for their time and very advanced mathematically. Do you know if those mathematics of the ancient structures have been captured and put into data sets that we can now use today to advance current structures?
Correctly, yes, absolutely. So, the shell that we did, the Knit Candela, for example, that was a collaboration I did. I work with Sahadit and the Block Research Group in Zurich. We work very closely with them, and they have all of the, for example, 3D graphic statics, ways of calculating shells and bridges from the 1800s, 1700s. They have captured that and now make digital tools for that. So a lot of that is coming from that kind of knowledge. So we do have a lot of and a lot of it's like a stone construction, for example. It disappeared because no one was able to do it anymore, right? But now we can calculate. We have tools to calculate all of that and to do it with the robot. So definitely the knowledge of all the structures is amazing, and the vernacular construction and where there were very little waste. There was no waste at all, right? So that's something that we have been working on like for at least like 20 years now. Like in really kind of like the shells that we have been building, all of them are looking at Felix Candela, at builders from the past that knew how to do efficient. A big problem, and to Jason's point, a big problem of a lot of those structures from the past is that none of them will pass code today. So I think that that's what we're also very excited to work here with the city, because unfortunately, like a lot of the code is not flexible or catching on, right? It's very top down. And when you think about, well, if you don't need so much concrete, you don't need so much like material or so much structural, why? Like cathedrals from the past are here today, thousands of years after, and our buildings keep being demolished. So I think that there is a big layer of risk that has to be taken in code and into saying, well, you know, I can calculate them, we can build them, we have built a bunch of them. Can we take the risk of having something that is like maybe not structurally as you will expect, but we can guarantee it will work? And a lot of these structures, what we do is we put like, sometimes for them to get them to code, we put like bags of sand, we load them, so engineers will see that they don't collapse, and then they will believe that we can build them, right? So I think that there is a big, that is not about calculating building and design, it's also about that risk, about like, and it's a very calculated risk, I will say, because we know that from the past, they have been there for a long time already. So I think that that's something we have been discussing with Jason a lot, and one of the exciting points of being here at the Wave is to kind of how can we test this and start to poke into that. Yeah.
Yes.
Hi, my name is Sarah. So I'm also a social innovation student at Nahmad University, and I'm taking the course like Civic Innovation, and we've done like a lot of observations on the city. And like our biggest thing, and like talking with other students as well, was that like the architecture seems like quite bland. And anyways, I just wanted to say it's really cool that you work with like Zaha Hadid. That's like sort of something that like we see as like international, not something that would be in like Calgary or something. So I feel like there is interest in like students. But like, what type of students would you be looking forward to like work with?
Excited students. I think that that's the more important thing. Students that are enthusiastic and excited, I love to work with them. Students that just want to like not take any risk and just want to be doing traditional stuff are the most difficult ones. I don't think it's about the skills, it's about believing on it. And we have a Zaha Hadid pavilion coming soon to be unveiled, right? It's in the making. We're aiming to fabricate parts of here with the big robot. So it will be coming soon. I'm very excited for that collaboration in the city of Calgary. We are working with them on the finalizing the project. But yes, I mean, I think that something also to your point about robotics and about the techniques is that ornamentation was very expensive at some point, right? In the past it wasn't, and now all the buildings maybe are bland because ornamentation, decoration is expensive. With digital fabrication, with the robotics, the 3D printing, ornamentation is cheap. There's no cost to it. And a lot of the times, like the pod I showed, the ornamentation was just from the gripper taking them, and people were like, oh, that's so beautiful. And that's just the machine the machine showing its own personality in a way, or its own thing. So how can we express that? And I think that it could be that we can get very much efficient ornamentation by engaging with machines, and not just efficiency through making more of the same.
Okay, thank you. You know,
Thank you.
Alicia is one of my favorite Calgarians, and she should be one of yours as well. So she's being very humble. So on top of working at the School of Architecture and Planning, and being a very recent top 40 under 40, right? Top 40 and 40 does a ton of work with Zaha, is bringing Zaha Hadid here for some conferences next month, but we'll have our first Zaha design in the city here, and it does some amazing work in Roatan, working, upskilling the locals with how to do 3D printing so that they can print housing first and then high-end housing at the end.
High-end housing, yeah.
With 3D printing. And there was one more thing I want to, and you just came back from teaching at Penn State as well, which is the
University of Pennsylvania.
University of Pennsylvania, which is like the premier design school in North America. So we're so lucky to have you here in Calgary, but also here in the Wave. And and then you talked about risk taking. And so that bench, we have one of those red benches over there. And again, we're a very small budget that was going to be going to leasing benches. We're able to take that and turn it into an amazing project that has lasted now 4 years almost.
Yeah, yeah.
But the risk taking was, you had all those pictures of students jumping on them and tons of students on them. We still had to pay an engineer, even though it was designed by one of the predominant architectural student, professor and designer in the country. We still had to have an engineer review it for about $7,000. I think it cost us.
And we had to send them the mesh because they didn't know how to calculate the curvature.
Yeah,
right?
exactly.
So we had to send them our calculations. So it was funny. Yeah.
Yeah. So that's just again an amazing example of where code has to catch up. But I want to thank you so much for coming here, and we can't wait to bring you back and share more stories.
Well, thank you so much, and I'm very, very excited to collaborate, and very inspiring to see the enthusiasm on the city. We are very, very excited. We have a few surprises coming. The pavilion, the conference next month. We're getting Sahadid, Foster's. So we're getting people from very high-profile offices are going to come to talk at the BAMF Center. So everyone is invited to come. It's called Acadia, if you're interested. Yeah.
All right.
Thank you.
Thank you so much, Alicia, and we'll chat soon. I'll take this.